Okay, we are learning about mixture and distance problem solving. This can be a tricky section, so we're going to spend a little bit of time on it. I know I've got this when I can solve mixture problems and solve distance problems. Go ahead and stop and read. Okay, example 1 says Mitchell has a bottle containing 80 milliliters of 40% HCl, I don't remember what that is, hydrogen chloride, I'm sorry, hydrogen chloride solution and a bottle of 15% hydrogen chloride solution. He wants a solution that is 25% hydrogen chloride. How much of the 15% solution must be added to the 40% solution so that a 25% concentration is created? All right, I'm gonna write what I'm thinking as I'm thinking it, but then I'll show you a table to help you organize this a little bit better, okay? But this is just what I'm thinking so far. Mitchell has a bottle containing 80 milliliters of 40% hydrogen chloride and a bottle, we don't know how much, of 15% hydrogen chloride. He wants a solution that is 25%. All right, so I'm going to have the quantities, the 80 plus this X of unknown quantity, and then I want a total solution that is 25. Okay, so we have the first solution of 40%. We have the second solution that's 15%, and then we want our total solution to be 25%. That is what I'm thinking right now. So they set up this table so that you can see. So again, 40% of the 80% solution, 15% of another solution, we don't know how much, gives us the total concentration that we want of 25% hydrogen chloride solution of the two combined volumes. So to find the volume of the hydrogen chloride, you would say 80 times that 0.4, X times the 0.15, and then you could say 80 plus X times the 0.25. There you go. Okay, so now we're actually going to solve the problem. So if you multiply this out, you get 32 plus 0.15x equals 20 plus 0.25x. Okay, now I'm going to solve it. So I'm going to subtract the 20 from both sides. Now I get 12 plus 0.15x equals 0.25x. Subtract the 0.15x from both sides. And now I get 12 equals 0.10x. Then if I divide that both sides by 0.1, I would get x equals 120. So you need 120 milliliters of the 15% solution. And then you can see that that says, so you solve it and then you interpret it, and then that makes sense. You need 120 milliliters of the 15% solution to be added to the 80 milliliters of the 40% solution to create the 25% solution. Okay, B says a collection of dimes and quarters are emptied from a drink machine. There are twice as many dimes as quarters, and there are 10 fewer nickels than there were quarters. If the value of coins was 1950, find the number of quarters, the number of dimes, and the number of nickels. All right, so let's see. I'm seeing if this is going to put it in. Okay, no, we're doing this. All right, so quarters, how much is a quarter worth? 25 cents. How much is a dime worth? 10 cents. And a nickel is worth 5 cents. Okay, it doesn't tell us how many quarters we have, but it does say we have twice as many dimes as quarters, and there's 10 fewer nickels than quarters. Okay, so the total value we would multiply that. Okay, and the entire collection, they tell us, is 1950. So basically, I'm going to add up all our coin values and have them set equal to 1950. And you can see here from my work in the last slide, it's exactly what I wrote. Okay, so we're just going to go ahead and work that out now. So I'm going to go 0.25Q plus, that would be 0.2Q plus 0.05Q minus, okay, if I multiply this by 10, that would be 0.5 equals 1950. Now I'm going to go ahead and combine all these like terms. So I have all this, so that would give me 45, so 50Q. And then I'm going to add 0.5 to both sides. So I get 0.5Q equals 20. And if I divide both sides by 0.5, I would get Q equals 40. So what does that tell me? That means I have 40 quarters. Then I need to know how many I have of everything. So there's twice as many dimes as quarters. So twice as many would be 80 dimes. And then there were 10 fewer nickels than there were quarters. So 10 fewer than 40 would be 30. So that is my final answer. Okay. Now this is one for you to do. How much pure acid should be mixed with 4 gallons of a 30% acid solution in order to get an 80% acid solution? So go ahead and pause the video and try to do that one. Okay, I'm going to go ahead and work it out. So I'm not going to do the whole thing. I'll set it up for you though. Okay, so 44 gallons of a 30% solution. How much pure acid? So that's 100%. So we don't know, but that's 100%. So realize I'm putting it in percent form, in decimal form. To get an 80% solution of the 4 gallons, and we don't know how much. Okay, so that is how you would set it up. And your answer should be 10 gallons. So when the amount in the formula is distance, we refer to the formula as the distance formula. So that is distance equals rate times time. While swimming in the ocean, Missy's sunglasses fell off her head. If the sunglasses fell at a rate of 4 feet per second, how long will it take them to fall 70 feet to the sand at the bottom? Okay, so remember, distance equals rate times time, right? So how long will it take for them to fall 70 feet at a rate of 4 feet per second? And the question is how long? So we're looking for time. So you divide by 4 and you get t equals 17.5. So it'll take 17.5 seconds for her glasses to fall 70 feet to the sand at the bottom. Moral of the story, don't wear your sunglasses in the ocean. There you go. All right, next. The fastest average speed by cyclists across the continental United States is 15.4 miles per hour by Pete Penseres. Let's go with that. If he traveled a total distance of about 3,107.5 miles at this speed, find his time cycling. Write the time in days, hours, and minutes. Okay, so we have, let's see. We've got distance equals rate times time, right? So distance equals rate times time. So it looks easy. You just divide. And when you do, you will get 201.79. Okay, but that okay. So that's in hours because this says miles per hour. So this is in hours, but we want it in days, hours, and minutes. So how do we do that? Well, how many hours are there in a day? 24. Hopefully you know that. Okay, so that would be 8.41 days. So if I just want it in days, then that would be good, but they want it in hours and minutes. So you take the 0.41 off of that 8.41, and how many hours are there in a day? 24. So you're going to multiply that by 24, and you're going to get 9.84 hours. But you still want minutes. So you take the 0.84. How many minutes are there in an hour? 60. So you multiply that and you get 50. So it takes him 8 days, 9 hours, and 50 minutes. And that is the fastest to go across the continental United States. That is really fast. Goodness gracious. And so this is just kind of setting it up for you. And then you're supposed to check your answer. Okay. 2B says, 2 trains are traveling on parallel tracks towards each other from a distance of 533 miles. If the freight train is traveling 27 miles per hour and the passenger train is traveling at 55 miles per hour, how long will it take them to pass each other? Okay, so you have this lovely picture of the situation. So the 2 trains are coming together, okay? They're traveling toward each other from a total distance of 533 miles. So from one end to the other is 533 miles. How long will it take them to pass each other? So what do? Let's see. So the distance traveled by the passenger train plus the distance traveled by the freight train is going to total that 533 where they meet in the middle. So we're going to use a table to find this. Okay, so rate times time equals distance. So we can say, all right, both trains start at the same time and meet at the same moment in time. So they traveled the same amount of time because they meet at the same time. Okay, multiplying the rate value by the time gives the distance. So 55 times t and 27 times t. And so you come up with, so the 2 distances of the train, right? So the 55t plus the 27t gives us that total distance of 533 miles. So if I do this, then all I have to do is add 55 plus 27. And what do I get? I should get 82. Yep. 82t equals 533. And then I just divide both sides by 82. And I get the time is 6.5 hours. And that's how long they have to travel before they meet up. There you go. All right, this is one for you to do. How long will it take a car traveling 60 miles per hour to overtake an activity bus traveling 45 miles per hour if the activity bus left 2 hours before the car? Use the following table to model. Okay, so you can use this to go ahead and solve that problem. So pause and work it out, and then I will help you in a little bit, but I want you to try it first. Okay, so I did this because the car's traveling at 65, the activity bus is traveling at 45. I don't like the way this table is set up. I wish those two were reversed. The time, you don't know how far the car is, but the bus left 2 hours before, so it has 2 extra hours. So since we want to know when they're going to meet up, we would set it up like this and solve. So if you haven't solved it correctly yet, pause it because I'm fixing to show you the answer. You should have gotten 6 hours. Okay, so I know I've got this when I can solve mixture problems and solve distance problems. In a mixture problem, 2 or more different quantities, such as peanuts and raisins, are combined to form a new mixture. How is the amount of the new mixture related to the different quantities that are mixed? The amount of the new mixture is the sum of the amounts of each quantity that are combined. What is the formula you use to solve distance problems, and what does each variable represent? Distance equals rate times time, and D equals R times T. All right, so I hope that helps, and y'all have a great day.